So good morning. Today I want to talk about the knowledge gap, and as the nice video just showed you, I'm Matthias. But today it shouldn't be about me. It will be about Dana. And Dana is a software developer who is working on an agentic system. She came up with an agentic system for project management, for all the project handling in her company. And she's really excited because she's about to pitch this project to the team, to all the decision makers, the stakeholders. And we will follow her on her journey today and just look into typical failures you can have when having agentic systems and trying to get knowledge in there, and just follow her on the way. We will focus on knowledge and how to put knowledge in your agent and what you can do and what could happen on the way. But first, let's have a look at her agent. The agent is called Project Pulse. As I said, it's about project management, so handling all the tickets and the documentation and Confluence and whatever exists in the company. And she's having the demo to the team.
This is Project Pulse, an AI assistant for project management. With this comprehensive project management tool, we can ask questions like, what tasks are currently in progress? The agent analyzes all Jira tasks, Confluence documentation, and all other available company resources. It then gives us the main tasks that are currently in progress for the team. Let's ask, when is the authentication deadline? The ticketing system, documentation, and other resources are checked to give us a quick and accurate answer. We can see the deadline for the ongoing authorization tickets right away. Now let's find out what Sarah is working on. Without checking Jira in detail, we can directly see her current task. With Project Pulse, our daily project management becomes much easier and smoother.
And this demo worked pretty well. The team was amazed. It's very helpful for them. Okay, it's just a mock project, but yeah, the team was amazed. It was a good demo. The project manager just said, like, I will use this every day. It's perfect. And the team lead just decided, let's bring it on tomorrow. Let's introduce it and directly start using it. And then day one started. And the next morning, the project manager just started working with it. And let's say, compared to the script demos, it didn't really work out. The results were mixed. Some were helpful, but a lot of issues and problems appear. For example, he was asking about some tickets in progress, and which of those are most urgent, and the agent has no idea what tickets we're referring to. Or the user asked, compare the mobile and the web authentication implementations. And the answer is not wrong, it's correct, but it's not really comparing the authentication implementations. It's just giving an answer of some frameworks being used and the difference of the two components. And sometimes it's just the wrong answer. So when he asked about what tasks were completed or how many tasks were completed last month, the answer is 3 tickets. And well, it could be correct, but Dana knows it's bigger teams. It's more than 100 tickets being completed in a month. So this is just wrong. And so Dana gets very, very disappointed. I mean, she spent a lot of work in there, and it's not really working. And some are some kind of obvious bugs. But some parts are really confusing for her as well. Like, she has no idea why this is happening. And let's have a look. And in the first step, of course, let's open the black box. Let's have a look what is actually going to the large language model and why. In general, a large language model is stateless, as you might know. So everything that is needed to actually answer the question needs to be sent to the large language model with every request. And of course, we're not sending the user query in raw format, but typically we're creating a prompt out of it, explaining a little bit the scope and whatever is needed for the large language model. And this could look like this. So of course, we are not only sending this message, but we typically have something like a system message setting the stage, explaining the scope. We have the message from the user, and we're typically having a model, and if you have some tools, those as well. This is the format by Anthropic. It could be a little bit different depending on the provider you're using. Now for Dana, it's a little bit of a Project Pulse. It's a little bit more complicated. She added a rack system because she wants to use all the information in the company. So she added a lot of ingestion pipelines for documentations, transcripts, mails, etc., and putting all these information in a vector store and using this before the actual agentic step. And the agent, of course, is then using a large language model to generate the answer. When we look at the messages, this means our user message is just bigger. All this context that is retrieved up front will typically just be added to the user message in front of the actual message. And when we now want to debug very complex message setups, we have a lot of back and forth in messages, and there's a lot of different information within a message. So we need some kind of abstraction, a logical abstraction of this information. And when we look at this like this, we typically have the system prompt, user prompt, and within, in between, we have a context. And this context could be very large. Like current models like GPT-5 has a context window of about the first complete 3 Harry Potter books. So we could just retrieve a lot of information and put it in there. Now let's move to the first issue. My agent has demand here. And it's a very simple issue. So when we look at the problem, we are referring to tickets from the answer before, and the agent has no idea what's actually going on. There's just one very obvious thing missing. We are missing the conversation history. I thought a lot about whether I should add it to my talk here, but I've seen a lot of projects where this is actually happening because people rely on libraries, for example, to do the history, but it's very important to be aware that when you're not sending something to the large language model, it don't know about it. So if you're not taking the messages from the call before and re-add it to the call, it's just not there. And in Dana's case, she forgot about it. So with this simple fix, we can already fix the first issue. It's more a bug. And let's move on to something more complicated. Let's talk about feeding the agent with the actual knowledge. And Dana, as I showed you, she has an upfront retrieval step. And to be very clear about this is completely fine. And if you need a some retrieval information in nearly every answer, this is still a good setup. But let's have a look if we can still improve on this. So we had the example compare the authentication implementations of 2 different components. And the answer is just something different. There is some kind of comparison, but it's more about frameworks and not the authorization implementation. So let's have a look at the context. And Dana directly sees in the context that there is a comparison of frameworks and not what we expect it to be. And the main reason is we just don't have an actual comparison in our data. There is no comparison of the authentication frameworks or implementations, but we have a lot of other comparisons. And now the problem is vector similarity doesn't mean relevance. So there are single documents explaining the authorization implementation. I have no idea why I choose such a complex word for this presentation, but the authorization implementation, we have something for the web component. We have a document explaining it for the mobile component. We have no comparisons, and all our other comparisons of these 2 components, we had bad luck, and they are more similar to our initial query. So the core question here is for nearly all RAG systems, why should my similar data actually be relevant for answering my question? And this is really like one of the core problems I had in nearly all RAG projects within the last 3 years. For example, for Statista, it's just very, very important to think about why should a user question, for example, be similar to some random statistic I have? It's not necessarily the case. It could be, but not necessarily. So most of the RAG projects are about having some kind of rewrite steps, some pre-processing of the query. So I'm taking the query and make it better suitable for retrieving my actually relevant data. Whatever this means. Typically, it means asking a large language model to write a better query. Or in our case, it would be very helpful to ask a large language model to split the queries if necessary. So not having just one query for the comparison, but for perhaps other queries asking for the specific content pieces that we then can compare ourselves. And now we have a big advantage here at Project Pulse. We already have a large language model that is handling a lot of stuff. We have an agentic system. So one thing we could do, we could just move our retrieval step to an agent, convert it to a tool, and just adjust the prompt a little bit that the agent is now asked to optimize the query or improve the query if necessary. So we don't need a separate retrieval step up front. As I said, it's not wrong. This is a different architecture. It has downsides as well. Could be that it's not doing a retrieval at all, but we want it to do. But that's fine. Let's look at the messages. Our agent now initially still asks the tool for the comparison. It looks at the result, and the result is not very helpful, as we've seen. Now it decides to do further requests, and it's doing 2 requests, one for the authentication implementation for mobile and one for web. And then finally, it can do the comparison itself and come up with the correct answer. Let's have a look at the next issue. There was one user asking how many tasks were completed last month. The answer is 3. It's wrong. Let's look at the context and let's expand it a little bit. This is the context for this query. So there are a lot of tickets in there. In this case, there are 10 tickets in there. And I mean, this is actually what RAG is doing, right? It's doing a retrieval. It's looking for similar documents. It's giving some number of similar documents, like I defined. In this case, it's 10. Of course, I have more than 10 tickets. And I'm asking for some count, for some abstraction. I could increase this to 20, to 100. I could fill up my context with all the tickets. It doesn't make sense. It's not a solution to put in all the tickets, and it will start to distract the model as well. And we can see the answer here directly what happened. So 3 of those 10 tickets were completed last month. So the answer is 3, but based on the context. The LLM has no idea that this is a subset of our data. So we need something different because RAG is not suitable for analytical queries. And I'm also seeing this at a lot of customers. It's very important to be aware because often people are building RAG systems, but the users that are actually using those RAG systems are not aware that they can't ask analytical questions. So they are asking for what are the most typical tickets in our subsidiary in New York? And it's just giving an answer, and they have no idea that's completely wrong. So we need something different. We need some system that is capable of doing those queries, like a BI system. Or it could be just our Jira API, where we can set some filters to come to an answer. So instead of using RAG, Dana just decided to introduce a new tool doing analytics, some Jira analytics, whatever this means. And with this new tool, we now have a better context. Our context is not just listing tickets, what is not very helpful, but it's directly giving a context like tickets resolved in October, 137. And with this context, of course, we can answer the query I just showed you. Now let's move on to connected data. Dana is already quite happy with the improvements. It doesn't feel like having a lot of bugs anymore, but some issues are still very confusing to her why the system is not getting it right. The system just doesn't feel very mature. We have, for example, questions for what are the risks to the November 15 deadline? And the answer is here, this is the deadline of the odd 123 ticket. It's currently in progress, 3 days buffer. This is not wrong. it's just not complete because the person working on this ticket, it's Sarah, by the way, and Sarah is also working on a lot of other tickets that are very important, and she's definitely a bottleneck, and there's a high risk for this deadline and for the project in general. And of course, this is quite difficult to answer with such a system, but Dana thought, like, all the information is in there, why shouldn't the system be able to answer it? Or another example, a user asked for the technical architecture of the web component. The answer is the web dashboard is built on Next.js and users and so on and so on. This is also not wrong. It's just very, very incomplete because there are a lot of documentations all over the company, a lot of distributed knowledge that is explaining the technical architecture of this component, and most of it is just missing here. And because she's quite she has no idea how to proceed. She has no idea why this is wrong. It's not so obvious as a bug. So she's asking a colleague called Priya, and she's asking Priya what to do if she has some ideas. And Priya is telling Dana about Graph and about GraphRec. It could be Flo instead of Priya. And GraphRec, if you've been at the talk of Flow, you know already a lot of about GraphRec. GraphRec in general just means I have rec, and I'm using a knowledge graph for my retrieval step somehow. I could use it additionally or instead of my classic retrieval, whatever. And as you have heard in the last talk, there are a lot of concepts about GraphRec. I will focus on a very specific one. In general, you could say like the GraphRec concepts could be broken down by how you construct the graph. So what data do you put in there? How do you build and set up the graph? You can do it manually by modeling your domain. You could have conversational memory, just question answers going in. You could have complex knowledge like here and building a so-called lexical graph out of it. On the other side, you could break it down in how you retrieve the data. How can we use the knowledge graph for a better context? And there are a lot of different approaches. As I said, I will focus on Dana's use case here. So let's start with the construction of the actual graph. And the first thing that Dana does is just still chunking a document. She's already doing it in traditional rec, so she's creating chunks of all the documents. She's adding the chunks and the document to the graph. The document just contains a name and perhaps a source, and the chunk now contains the actual text. And then she's also generating embedding for the chunk text. So the nice thing here is we are not losing anything compared with traditional rec. We still have embeddings of the original content, and we can do a similarity search on it. Now in the next step, we can ask a large language model to extract entities out of it. So we ask a large language model, this is the chunk, what are the entities in there? And we can add it as dedicated nodes. And of course, we can also ask a large language model for relations. So how are these entities related? We could use generic names like relates to and then add a description explaining the relation in detail. Or of course, we could also use specific names for the relations like is working on. It depends a little bit on your data and what you want to achieve. And this already adds a lot of additional value to our data. We are not limited to the raw chunks anymore, but we have the structure and the relations now within the data. But we can enrich it even more. We could, for example, ask a large language model to generate a summary for a specific entity based on all the related informations. So now we are not limited to the raw information and that an entity exists, but we could look at all the relations of this entity, like a web component, for example, and generate a summary out of it. So we now have abstracted and summarized information within our graph that doesn't exist before. And of course, we could also generate embeddings for the name and the summary of an entity. So we could also use it in similarity search. And here in the similarity search, we are also not limited anymore to just the raw information. And let's have a look at an actual graph. Let's see if it works. So this is Neo4j. And I generated some test graph. And what you can see here, let's zoom in a little bit. This, for example, is one of the raw contents. It's not chunked here because it's quite small, but this is, for example, a ticket. It's our ticket ORT123. Here we have the ticket entity that was extracted out of it. And we can see a lot of properties here. We already see a summary explaining all the information about this entity node. And we see all the relations. Let's have a look where Sarah is. Here she is, Sarah Martinez. So here we have a person node, also with a description and the embeddings and so on. And we have our relation that is responsible for in this case. So we have all this information in such a graph. And as you can see, it can become quite big. OK, so we constructed a graph. We added additional information. We added summaries. We added embeddings and so on. Now the question is, how can we use this graph to really create a better context? And one thing you can do, for example, is also extract the entities from the query and then look up the entities in the graph and then traverse the graph from these points. One thing I'm seeing most often is still starting with the similarity search. So we're doing some kind of traditional RAG, but now not just on the chunk data, but also on these summaries and entity names, and perhaps also relations, depending on what we embedded. And what we then can do, we traverse the graph and we enrich with further information that is also relevant for this topic. That is perhaps not similar enough for our initial question, but it's still related to this context, and it can still be valuable for answering our questions. So when we now would create a context out of this, we will have similar chunks, like traditional RAGs. We will have similar entities with a summarization information from all the chunks, relations, and other entities. And we have related entities we would have missed before with their relations and also, of course, their summaries. So it's now much more advanced what we have in context. And we could put everything in there. There are a lot of funny ideas on how to format it. It really depends on you and depend on your use case. You could just put in all the chunks and the entities and the relations like this. And now when we use this kind of information, we are able to answer something like this. So when we ask for the technical architecture of the web component, it already has an entity about the web component, including a summary that includes all the information from the complete graph that is related to the web component. And if we ask about, for example, our deadline, the LLM now already has some information about who's working on the ticket that has the deadline, what tickets are also, what other tickets are Sarah also working on, and can identify this block and can really give a correct answer that this deadline is at risk. Now, Dana fixed all the main issues. So she thought she's fine. Well, the context became a problem. We put a lot of information in there, right? So we have now a history. So if you have a longer conversation, it's just a lot of information in there. And you're doing graph rag retrieval in nearly every step. And it's a lot of information there and related information. And then the next chat, it's again and again. And it's becoming really big. And of course, I mean, I told you there's a lot of space within a context window. But LLMs have very typical problems with this. They are getting distracted with a lot of information. And they are just getting confused. So the reason is for the large language model, it's not like this is background information, this is my actual question. It's really like, this is everything you need to know, including the question, please answer it. And it could be very distracted. Typically, it starts to decrease in quality a lot after about 50% of the context window is filled. Depends a little bit on the models. It will be improved with every new model release currently, but you shouldn't completely fill up your context window if you don't have to. There's also the risk for context poisoning. So if you have longer conversations, perhaps you wrote something that is wrong, or there's a retrieving some error within your data. Now the error is within your context, and it will stay within your session until you reset the session. So there are some problems with very big or with a lot of data in your context. And often it's even not, it's hard to figure it out, because at some point Dana's system could give an error because the context window is exceeded and it doesn't fit in there. But often, as the context window is so big, it's just decreasing in quality over time, and you have no idea why. It's suddenly giving bad answers. And what you can do, or the first thing you could do, is context selection. So really think about what should be in the context and what can I just remove from it. So if we break it down, we have a lot of different context pieces. We have a lot of different conversation messages within our context after a while. The first very easy thing is we could do deduplication, because we did perhaps a lot of graph rec requests and retrieve a lot of entities or chunks, and the chunks again, and the chunks again, and so on. So there is redundant information within our different context. And after deduplication, we could, of course, just remove older messages. And just expect, like, if there is a message, a tool response, some graph rec retrieval result, a message within the conversation history that is older in a long conversation, it's just not relevant anymore. Let's get rid of it. And perhaps if you have enough space, perhaps it's just about the long tool responses. Tool responses are really big. Perhaps you want to preserve the messages because they are helpful in the conversation, but the tool responses could be removed. Or if you don't want to remove it because there is relevant information in there, you could just look for relevant information. You could ask a smaller large language model to go through all the messages and context pieces and just classify if this part is relevant or not. So get rid of all this chit-chats in between your messages. Or of course, if you're worried that you're losing information just because it's old, or you have wrong classifications for relevance, you could of course just summarize older parts. And the summarizations are, of course, quite small. So you could, this is what happens often in those systems, you could just take older messages and create summarization out of it. Now, regarding context curation, as I showed you, there's a lot you can do. And it's very important here just to keep in mind what you can do. It's not too much about what you actually do, as long as you validate what is the effect and what you can improve afterwards. We could do it after each message, if we like, or we could do some of these parts after each message. We could do it when the context is exhausted or partially exhausted, whatever makes sense for our data. So for Dana, she decided to summarize large tool responses nearly immediately. So she's using the tool response in the first answer, but directly after the first assistant answer, she's summarizing it to not keep very large tool responses at all in the context. She's removing stale tool responses. So when the tool response is older than, for example, 10 conversations, then she's just getting rid of it. And she's summarizing old messages as well, but only if the context window used is above 50%. And with this setup, she already improved the context a lot. It's more slim, it's more useful, again, for the large language model. Now, from day one to production ready, let's have a small recap of what happened here. Dana introduced conversation memory. And if you have a chat situation, you should have some kind of short-term memory here. She introduced a multi-query rewrite for the RAG to just improve the query, because the original user query is often not suitable for doing RAG. She introduced an analytics query tool to also be able to answer analytical questions, because this is not possible for RAG systems. She introduced graph rec with multi-hop retrieval to also get related information and not be limited on the original raw data. And she also added LLM-generated entity summaries to have more aggregated information accessible within the system. And then she introduced very strategic context selection and compacting to keep the context overall clean in the agent. Now, this is about Dana. I'm also working on these knowledge and context management systems for a while now. If this is relevant for your company, let's get in touch. This is my LinkedIn. Especially, I'm working on a stealth project for the whole year that is trying to solve this problem. So even adding more quality than just a graph rack and adding more context that is relevant to agents. So if you're interested in this, let's get in context and I get you on the private beta list. And with that being said, thanks a lot for your attention.